My name is Karen Daly and I teach mathematics at DKIT, a third level college in Ireland. This video was produced to further assist my first year computing students with their mathematical studies. By working through a typical question in sequences and series, at the end of this tutorial you should have an understanding of the fundamentals of this topic. Enjoy! Let's start with arithmetic sequences. An arithmetic sequence is an array of numbers in which each term is found by adding a fixed number to the preceding term. This is called an arithmetic sequence, or sometimes an arithmetic progression, sometimes shortened to an AP. First example says, consider the following arithmetic sequence: 2, 6, 10, 14 and 18, all the way up. And the part 1 says, state what A and D are for this sequence. Now this sequence is arithmetic because to get the term above the previous term, what we continually do is we add 4. So you can see you add 4 to 2 to get 6. We add 4 to 6 to get 10. We add 4 to 10 to get 14. And we add 4 to 14 to get 18. So you can easily generate the term above 18 by just adding 4 to it. So the next term up would be 22. Now, what are the values for A and D? Well, let's look over here to the right hand side. Here I'm given the general term of an arithmetic sequence. The general term is an is equal to a plus n minus 1 multiplied by d. And it tells me that a is actually the first term. So if we go back here to our sequence, a is the first term, so a in this case is equal to 2. It tells me here that d is the common difference. And the common difference is the number that you add to the previous term to get the next term. So d in this case is equal to 4. And that's part 1 answered. Now for part 2, what I'm asked to do is to find A40. Now I've been given a formula for the general term, so I'm going to use that. So in this case I'm looking for when the value of n, when n is equal to 40. So I'm going to put down n is equal to 40. And I'm going to fill out this formula here with everything I know. So I have that A40 is equal to A, which is equal to 2, plus n minus 1. n is 40, minus 1, and it's multiplied by d, and d has a value 4. So remember, you always work out a bracket first. So 40 minus 1 is 39, and that's multiplied by 4. Now remember, you always multiply before you add, so it's 2 plus 156, and add 2 to that, you'll get 158. So the answer to A40 is 158. Now let's move down the page and do the next part. Now just like before, we're given the formula in the exam. So this here is also given in the exam. The sum of n terms of an arithmetic sequence Sn is equal to, and this is the formula for it. So again, n here is equal to 40, and if I put in everything I know, what I'll find is, I'll start over here, S40 is equal to, n is 40, so it's 40 divided by 2, multiplied by 2a, remember a was equal to 2, so it's 2 by 2, plus n minus 1, again n is 40 minus 1, multiplied by d, and d was equal to 4. So I'll just close the bracket there. Now that's equal to 40 divided by 2 is 20, multiplied by 2 2's are 4, plus 40 minus 1 is 39, and you multiply the 39 by the 4. Remember, you do multiplication before you do addition, so that's equal to 20 multiplied by 4 plus, and we've already got the answer to this, 156. So that's equal to 20 multiplied by 60, and 20 multiplied by 60 turns out to be, that's 160, And 20 by 160 turns out to be 3,200. So the answer to that part is 3,200. So if you were to add up the first 40 terms of that arithmetic sequence, the value you would get is 3,200. Now let me move on to the next example. The next example is exactly the same as the previous one. I just use a new arithmetic sequence. Now, part A of the question is fairly straightforward, hopefully. You're asked to state what A and D are for this sequence. Now, A is very straightforward because A is just the first term. So A in this case is just equal to 2. D is the common difference. What do you add to the first term to get the next term? Now, in fact, it's gone down. It's gone from a 2 to a 0. So what you're doing is you're adding a negative number or subtracting a number, as the case may be. So you're subtracting 2. So D is equal to minus 2. Now you can check that that's the case because to go from 0 to minus 2, which is the second to the third, you're subtracting 2. From minus 2 to minus 4, you're subtracting 2. And likewise from minus 4 to minus 6, you're subtracting 2 also. Now for the next part, you're asked to find A34. Now remember, you're given the formula for the general term, and it looks like this. AN is equal to A plus N minus 1 times D. We have N for this particular part. N is 34, so you have that A34 is equal to A, which is equal to 2, plus N minus 1, and N minus 1 is 34 minus 1 times D, and D is equal to minus 2. Now what we have to do is work this out. Remember, we work out the bracket first, so 2 plus 34 minus 1 is 33, and we have to multiply that by minus 2. Again, make sure that we do the multiplication first. Be careful of the sign. A plus by a minus is a minus, so that'll be equal to 2 minus 33 by 2 is 66, and 2 minus 66 is equal to minus 64. So that's the sum, that's the term A34. So it's the 34th term of this particular sequence. Now let's look at the last part of this question. Find S34. S34 is the sum of the first 34 terms of this particular sequence. Now again, remember that you're given the formula. The general formula is Sn is equal to n divided by 2 multiplied by 2a plus, that's an a, sorry, plus n minus 1 multiplied by d. Now filling this out, n is 34, so we're looking for S34 is equal to, so it's 34 divided by 2 multiplied by 2a, a is equal to 2, plus n minus 1, n is equal to 34 minus 1 times d, and for this particular sequence, recall d was minus 2. So we've got a bit of a calculation to do, and we'll do it in stages. 34 divided by 2 is 17, right? 2 2's are 4, plus, again we have to work out the bracket. 34 minus 1 is 33, and we have to multiply that by minus 2. Again, going on to the next line, that's 17 multiplied by 4 plus, do the multiplication, it's minus 66. A plus by a minus will give me a minus, so that's 17 multiplied by 4 minus 66 is minus 62. And you can take out your calculator to do this last part. 17 multiplied by minus 62 turns out to be minus 1054. So if we were to add up the first 34 terms of this particular sequence, we'll get the sum total of minus 1954. Now let's move on to the next example. Let me move the page up here. This question reads, the first term of an arithmetic sequence is 2.7 and the common difference is 3.1. Write out the first 4 terms of the sequence. Now, the first term of the sequence is very straightforward because it's given in the question. It says the first term is 2.7. So we're going to just write that down. 2.7 is the first term of the sequence. Now we're also told the common difference, and the common difference is 3.1. And to generate an arithmetic sequence, we add the common difference to the previous term. So to get the next term, we take 2.7 and we add 3.1 to it. So the term will look like 2.7 is the first term. The next one is 2.7 plus 3.1, which turns out to be 5.8, comma. To get the next term up, we take the previous term, which is the 2.7 plus 3.1, and we add again another 3.1 to it. And if you add these three together, what we get is 8.9. Now, that continues on. So to get the fourth term, basically I take 8.9 and I add 3.1 to it, and the fourth term turns out to be the value 12. And it continues on and on like that forevermore. Now part 2, we're asked to write out the formula for the nth term of this sequence. Now remember, in the exam you're given the formula for the nth term, and it is that an is equal to a plus n minus 1 multiplied by d. Now we know the value for a and we know the value for d because we're given it in the question. So if we replace them, a is equal to 2.7 plus n minus 1 times d, and d is equal to 3.1. Now that is the formula for the nth term of the sequence, but we can simplify it a little bit using algebra. So let's do that. That's 2.7 there. So what it's equal to, an is equal to 2.7 plus. Now you can multiply this bracket here by 3.1 and you'll get 3.1n minus 3.1. Now if we bring together the figures, we have 2.7 minus 3.1 is equal to. So it'll be 3.1n minus 0.4. So that's it in its simplified version using a little bit of algebra. Now let's move on to part 3 of the question. Let's move on to part 3. Let me just get rid of that there. Okay. Now part 3 of the question says, what is the 44th term in the sequence? Now we can use what we have above here, and we have the formula for the nth term. an is equal to 3.1n minus 0.4. We're asked for the value of an when n is 44. So a44 is equal to 3.1 times 44 minus 0.4. Again, make sure you do the multiplication first, but you'll naturally do that first anyway. And what you'll get is, when you work all this out, you get the value 136. So the 44th term in this sequence has a value of 136. Now, part 4 of the question asks us to write out the formula for the sum of the first n terms of the sequence. Now for an arithmetic sequence, we're given the formula for the sum of the first n terms, and the formula looks like this. Sn is equal to n divided by 2 multiplied by 2a plus n minus 1 times d. So we're given that formula in the exam. Now if we put in what we know the a value, and that's 2.7, and we know the d value, that's 3.1. So if we put that in, we'll have that it's equal to n divided by 2 multiplied by twice 2.7 plus n minus 1 times d, and d is 3.1. Now again, using algebra and some arithmetic, we can tidy this up a little bit. So let's set about that. So it's n over 2. Now this is the formula for the nth term, and it could be used in this form, but we can tidy it up a little bit. So let's do that. 2 multiplied by 2.7 is equal to 5.4. And we can multiply this out. 3.1 multiplied by n is 3.1n, and minus 1 by 3.1 is minus 3.1. We can bring these two figures here together, and what we'll get is that it's equal to n divided by 2 multiplied by 3.1n plus 2.3. Now we can proceed one step further by multiplying the bracket by n divided by 2. So n multiplied by 3.1n will give me 3.1n squared, and then divide it by 2 and we get 1.55n squared plus n multiplied by 2.3 is 2.3n, and then divided by 2 we'll get 1.15n. So using algebra, that is the simplest form that I can bring it down to. Now if I'm asked to find in part 5 the sum of the first 54 terms of this sequence, well, I can just use this formula above here. Sn is equal to 1.55n squared plus 1.15n, and substitute for n the value 54. So S54, the sum of the first 54 is 1.55 multiplied by 54 squared plus 1.15 times 54. So definitely take out the calculator there and do this as a calculation and check, do you get the same answer as me? I got 4,581.9 as being the answer to that particular question. Now let's move on to the next section, and here I'm introducing geometric sequences. A geometric sequence is an array of numbers in which each term is formed by multiplying the preceding term by a fixed number. It's called a geometric sequence, or also can be called a geometric progression, shortened sometimes to a GP. Let's look at the first example. It says, consider the following geometric sequence. The sequence is 2, 6, 18, 54 and 162. Now, to check that it's geometric, first term is 2. To get the next term 6, what number must we multiply 2 by to get 6? Obviously the answer is 3. We multiply it by 3. Now we can see to go from 6 to 18. Basically, again, we do the same thing. What number do we multiply 6 by to get 18? Obviously, it's 3 as well. We multiply 18 by 3 to get 54, and we multiply 54 by 3 and we get 162. So it is a geometric sequence as I had described. Just like for the arithmetic sequences, for the geometric sequences we're given the formulas also. And the formula for the general term is written here on the right hand side. An is equal to a multiplied by r to the power of minus 1, where a is the first term and r is the common ratio. Now for part 1 of the question, we're asked to state what a and r are for this sequence. Well, a is the first term, so we're going to write that down. A is equal to the first term, and that's very straightforward, is equal to 2. R is the common ratio. That's the number that you multiply the previous term by to get the next term. So that number, as we just discovered earlier on, is 3. We multiply the previous term by 3 to get the next term. So that's that part done. Part 2 asks us to find A12, the 12th term of the geometric sequence. Putting it into the formula above, what we will get is that A12 is equal to A, and A has a value of 2, multiplied by R, and R has a value 3, to the power of n minus 1, so it's 12 minus 1. That's equal to 2 multiplied by 3 to the power of 11. And if you take out your calculator, work out 3 to the power of 11, multiplied by 2, what you should get is 354,294. So that's the answer to part 2. Now let me move on to the last part of the question. And the last part of the question is I'm asked to find S12, the sum of the first 12 terms of the geometric sequence. Now in the exam, we're given the equation for the sum of terms. And we're given two equations for Sn. One of them is for when the absolute value of r is greater than 1. So when the value of r, whether positive or negative, the absolute gets rid of the negative sign, is greater than 1, or when the absolute value of r is less than 1, we choose which formula to use. Now in our case, the r value is equal to 3. So the absolute value of r is equal to 3 also. So and 3 is a value greater than 1. So we're going to be using this first formula here. So if we put in the n value as being 12, S12 is equal to a, and the a is 2, multiplied by r is 3, to the power of 12 minus 1. All divided by r again is 3 minus 1. Now we just have to be careful in how we calculate this. Calculate all the top of the line, all the bottom of our fraction, and then lastly do the division. So let's do that. So to calculate the top of the line, I have to actually work out 3 to the power of 12 and subtract 1 from it first. 2 multiplied by, take out your calculator, do that, and what you should get is 531,440. Check that answer. And it's all divided by 2. Obviously the 2 above the line and below the line will cancel, so that just turns out to be 531,440. So if I was to add together the first 12 terms of this particular sequence, I'd get the answer 531,440. Now let's do another similar example. Consider the following geometric sequence: minus 1, minus 0.5, minus 0.25, minus 0.15, and state what a and r are for this sequence. Now, a for this sequence is very straightforward, because a is just the first term. So a is equal to minus 1. To find r, we ask ourselves the question, what do I multiply minus 1 by to get minus 0.5? Now the answer, of course, is going to be plus 0.5. So if I multiply minus 1 by a half, or 0.5, I get minus 0.5. Now check again on your calculator if you need to. Take out your calculator, take minus 0.5 and multiply it by 0.5 and see, do you get minus 0.25? You do. Take minus 0.25 and multiply it by 0.5 and see again, do you get minus 0.0125? And of course you do. So that means then that my r value is equal to, that's the common ratio, it's equal to 0.5. Now part 2 asks me to find A20, or the 20th term of this geometric sequence. Recall that we have a formula that will be given to us for this, that an is equal to a times r to the power of n minus 1. So if we put in what we know, we have that A20, n is 20, is equal to a, which is equal to minus 1, multiplied by r, which is 0.5, to the power of 20 minus 1, and 20 minus 1 is going to be equal to 19. Now if you take out your calculator and work out 0.5 to the power of 19, it's going to be a very small number, right? And then if you multiply it by minus 1, it just gives it as a negative value. So you're going to end up as being minus 0. I'm just going to write it in its decimal form. 1, 2, 3, 4, 5. There's 5 zeros there. And then the number comes to be 1907. If you wanted to write it in scientific notation, what you'd find is that it's minus 1.907348, and there's a good few digits after that, but it would be multiplied by 10 to the power of minus 6. Now either answer, they're both the same. This one here is just in normal decimal form. This here is in scientific notation. Now let's move up the page to do the last part. And what we're asked to do is we're asked to find S20, the sum of the first 20 terms of the geometric sequence. Now the value that we have for R, the absolute value for R, is equal to the absolute value of 0.5, which is equal to 0.5. And this value is actually less than 1. So for this question, we will be using the other formula than we did in the last example, and the formula is that Sn is equal to a times 1 minus r to the power of n, all divided by 1 minus r. That's the formula for the modulus of r less than 1. So if we put in everything we know, we'll find that S20 is equal to the a value we have for this particular sequence is minus 1, multiplied by 1 minus 0.5 to the power of 20, all divided by 1 minus r, and the r value is 0.5. Now if you work that out, remember we have to work out 0.5 to the power of 20 first, then take 1 and subtract that value from it. Now that's going to be a very small number, right? 0.5 to 20 is a very small number, so when we subtract it from 1, it'll have little effect really on 1. So what we'll discover is that it turns S20 is equal to minus 1 multiplied by, so it turns out to be 0.9999999.046, and that's all divided by 1 minus 0.5 is 0.5. And if we continue that, working that out in the calculator, we get that it's minus 1.92345. There's 5 nines, and then there's an 809. So it's a value very close to minus 2. Now let's look at the next example. The next example says the first term of the geometric sequence is 5.3, and the common ratio is minus 0.25. And what we're asked to do is to write out the first 4 terms of the sequence. Now the first term obviously is very straightforward because we're given that value. The first term of the sequence is 5.3. Now to get the next term of a geometric sequence, we take the previous term and we multiply it by the common ratio. So we take 5.3 and we multiply it by minus 0.25. Now you may need to take out your calculator to do that, but if you do, what you'll discover is that the answer is minus 1.325. Now again, to get the next term, you take the previous term and you multiply it again by the common ratio, which is minus 0.25. So minus 0.25. So again, basically we're taking this value here and we're multiplying it by, again, minus 0.25. And again, if you take out the calculator to do this, you'll get the value 0.33125. And then to get the fourth term, we take this term here and multiply it by the common ratio, which is minus 0.25. And what you should get is minus 0.0828125. And that's the fourth term. And obviously there are many terms outside that as well. Now the next part of the question asks us to write out the formula for the nth term of this sequence. Now we're given the formula in the formula sheet in the exam, and the formula is that an is equal to a times r to the power of n minus 1. So all we're asked to do is fill out the value for a and fill out the value for r, and then we have the general formula for this particular sequence. So an is equal to a, which we turned out to be 5.3, multiplied by r, which was minus 0.25, and it's all to the power of n minus 1, and that's the answer. Part 3 asks us to specifically find the 10th term of the sequence. So what we're going to do is we'll take this formula here that we just wrote down and we put in n equal to 10. So we find that A10 is equal to 5.3 multiplied by minus 0.25 to the power of 10 minus 1. And 10 minus 1 is obviously 9. So we take out the calculator and we work out minus 0.25 to the power of 9. It's going to be a very small number. Then we're going to multiply it by 5.3. So check that you get the same answer as me. I'm just going to write it in a decimal form. 0. And it turns out that there's 4 zeros. 1, 2, 3, 4. And then it's 20217. And that's the answer then to part 3 of the question. Now just let me move up here slightly to do the last 2 parts of the question. Part 4 asks me to write out the formula for the sum of the first n terms of the sequence. This formula is given to me and I have to see which version I need. So the common ratio, or for this particular question and the modulus of it, or for this question turned out to be minus 0.25. So the absolute value of that is equal to 0.25. And that actually turns out to be a value that's less than 1. So the formula that I will need is that Sn is equal to A multiplied by 1 minus r to the power of n, all divided by 1 minus r. So all I can do for the nth term is to put in the value for A and the value for r. So what I get is that Sn for this particular sequence is equal to A, which is equal to 5.3, multiplied by 1 minus r. And r has a value, and I'm going to put it in a bracket, minus 0.25, all to the power of n. And I'm going to close the bracket there, all divided by 1 minus r. So it's 1 minus 0.25. Now for part 5, I'm asked specifically what is the sum of the first 10 terms of this sequence. So if I go back to the previous part and use this formula, putting in n equal to 10, I get that S10 is equal to 5.3 multiplied by 1 minus 0.25 to the power of 10, all divided by 1 minus minus. Well, when a minus and a minus come together, I get a plus. So I'm going to write that down. 1 plus 0.25. Now here again, I have to take out my calculator and I have to work out minus 0.25 to the power of 10 as a number. Then what I'll do, well, I'll subtract it from 1. It's going to be a very small number, so when I subtract it from 1, I'm going to get a value very close to 1. So I'm going to get 5.3 multiplied by, so it's going to be 0. And the number of 9s is going to be 6. 1, 2, 3, 4, 5, 6. And let me squash in the rest of the number. I got 0.46. Put a bracket around it. And then all of that's going to be divided. 1 plus 0.25 is going to be 1.25. So again, taking out the calculator, multiplying that number by 5.3, and then dividing the answer by 1.25, what you should get is that S10 is equal to 4.24. Now I have rounded that off to 2 decimal places. So that's the answer to S10. Now let me move up the page here and move on to the next topic of this video. A sequence can be generated using a formula definition or a recursive definition. So let me give you an example of that. Example 1 says, write the first 4 terms of the following sequence. Now what I'm given here is the formula definition of a sequence. An is equal to 5n minus 3 for n equal to 1, 2, 3, 4, 5, 6, 7. And I'm asked to write out the first 4 terms of this sequence. Now the first term, using the counter, n is equal to 1. So the first term is called A1. And I get it by substituting wherever n is, I put in 1. So A1 is equal to 5 times 1 minus 3. That's 5 minus 3, which is equal to 2. To get the next term, I go up the next value of n equal to 2. And I put in n equal to 2, and I get a2 is equal to 5 times 2 minus 3. 5 times 2 is 10, minus 3 is 7. The next term is n equal to 3. a3 is equal to 5 times 3 minus 3. That's 15 minus 3, and 15 minus 3 is equal to 12. And then the fourth term that I'm asked to generate is when n is equal to 4, I'll get that a4 is equal to 5 times 4 minus 3. So 5 by 4 is equal to 20, and 20 minus 3 is equal to 17. So the four values are 2, 7, 12, and 17. Now let's look at part 2. Part 2, bn is equal to 4 times 3 to the power of n plus 1. This is a formula definition, and the formula works for n equal to 3, 4, 5, 6, and so on and so forth. So the first term of this particular sequence occurs when n is equal to 3. When n is equal to 3, we find that b3 is equal to 4 times 3 to the power of n plus 1, and n plus 1 is 4, 3 plus 1. To get your calculator, work this out, and what you find is the first value is 324. The next term is when n is equal to 4. So putting that in, you find that b4 is equal to 4 times 3 to the power of 5 in this case. Again, with your calculator, you can solve this as being the value 972. Next value, n equal to 5, we have that b5 is equal to, again, 4 times 3 to the power of n plus 1, which is 3 to the power of 6. And again, using your calculator, this turns out to be 2,916. And lastly, the fourth term, n equal to 6. b6 is equal to 4 times 3 to the power of 7. And using your calculator again, the value turns out to be 8,748. Now part 3, the formula is given by this particular equation here. Cn is equal to 7 times Cn minus 1 minus 2 times Cn minus 2. Now Cn minus 1 is just the term previous to Cn, and Cn minus 2 is just 2 terms previous to Cn. So this here is called a recursive formula, and to generate it we have to be given values, the initial values, 1 and 2. Right? So we're actually given the first two terms of the sequence. So C1 is actually equal to 1, and C2 is actually equal to 3. So that's the first two terms of the sequence without having to do any work. Now to generate the third term of the sequence, well, the third term occurs when n is equal to 3. Now if you put n equal to 3 into the recursive formula, we'll find that C3 is equal to 7 times C, n minus 1, 3 minus 1 is C2, minus twice C, n minus 2, 3 minus 2 is C1. Now we know the values for C1 and C2, so if you put them in, it's 7 times C2, which is 3, minus 2 times C1, which is 1. And if you work that out, 7 3s are 21, minus 2, 21 minus 2 is 19. So that's the third term of the sequence. Now, to generate the fourth term of the sequence, that occurs when n is equal to 4. We work out C4. Going back to the formula, it's 7 times C, n minus 1, n is 4, 4 minus 1 is C3, minus twice C, n is 4, 4 minus 2 is 2. So putting in the values, that's 7 times C3, and C3 has a value 19, minus twice C2, and C2 has a value of 3. Now maybe you need a calculator to do this. Multiply 7 by 19 and subtract 6 from it, and the value turns out to be 127. So that's the fourth term of that particular sequence. Now let's look at part 4. dn is equal to 2 to the power of n minus 5. That's a formula definition, and it's for n equal to 1, 2, 3 and 4. Okay, so again we just start off, well, when the first term is when n is equal to 1, d1 is equal to 2 to the power of 1 minus 5, and 2 minus 5 is minus 3, so that's the first term. Continuing on, when n is equal to 2, we'll find that d2 is equal to 2 to the power of 2 minus 5. 2 2s are 4, minus 5 is minus 1. Continuing on, n equal to 3, we discover that d3 is equal to 2 to the power of 3 minus 5. 2 to the power of 3 is 8, minus 5 is equal to 3. Continuing on again, n equal to 4, we'll discover that d4 is equal to 2 to the power of 4 minus 5, and 2 to the power of 4 minus 5 is equal to 11. And for the last part 5, en is equal to twice en minus 1 is the formula. Now that's a recursive formula, and you're told that e1 is equal to 4. So you've told the first term, when n is equal to 1, e1 is equal to 4. You're given that to start off with. Now the next term is generated when n is equal to 2. So e2, putting this into the formula, it's twice e1 minus 1 and 2 minus 1, and 2 minus 1 is 1. So it's twice e1. e1 is 4, so it's twice 4, which turns out to be 8. The next one, n equal to 3. e3 is equal to twice e to the power of n minus 1. 3 minus 1 is 2, so it's twice 8, and twice 8 is equal to 16. And then the last one, n equal to 4. e4 is equal to twice e to the power of n minus 1 is 4 minus 1, so it's twice e3, so it's equal to twice 16, which is equal to 32. Now let's look at the last part of this question. You're given the definition fn is equal to 5n plus twice fn minus 1. This is a recursive definition. You have to be given the first term to generate it. So the first term, when n is equal to 1, f1 is given as the value 3. To get the next term, we go to the formula, and it says that fn is equal to 5 times n, f2 is equal to 5 times n, which is 5 times 2, plus twice fn minus 1. n minus 1 is 2 minus 1, so it's f1. So that's equal to 10 times 10 plus twice f1, and f1 has a value 3, and 10 plus 6 is equal to 16. If we get the next term, n is equal to 3, we find that f3 is equal to, well, it's 5 times 3 plus twice fn minus 1, and again 3 minus 1 is f2. So it's equal to 15 plus twice 16. Twice 16 is 32, and 32 plus 15 is equal to 47. So that's the third term. To get the fourth term, n equal to 4, f4 is equal to, well, it's 5 times 4 plus twice f3 this time. So 5 times 4 is 20 plus twice 47. And if you do that as a calculation, you'll get 114. So there's the 4 values there, underlining them. Now, the next part asks us, state if the sequences above are arithmetic, geometric, or neither. I would like you to try this yourself. Print out the Word file that is attached beneath this video and answer this question for parts 1 to 6. The solution is: part 1 is an arithmetic sequence. Parts 2 and 5 are geometric sequences. And then the other 3 parts, parts 3, 4 and 6, are neither arithmetic nor geometric. Now let me move up here to do the very last part of for this tutorial. Here we're looking at a series. Now, what is a series? Well, if you've given a sequence, then the sum of all the individual terms of the sequence constitutes a series. So this example asks, evaluate the infinite sum of 2 plus 1 plus 0.5 plus 0.25 plus all the way up. This is a geometric series. A geometric series with A equal to 2 and R equal to 0.5. To go from 2 to 1, I multiply it by a half or 0.5. To go from 1 to 0.5, I multiply it by 0.5. So the first term is 2 and the common ratio is 0.5. Now in the exam I'm given that if the absolute value of R is less than 1, then the formula for the sum to infinity, or the sum of all the terms of the sequence, is equal to A divided by 1 minus R. In this particular case, we have that the modulus, or the absolute value of R, is equal to the absolute value of 0.5, which is equal to 0.5, and indeed that is a value less than 1. So this formula here holds. So to work out the infinite sum, S infinity, I have to just put in the values into the formula. It's A, which is equal to 2, divided by 1 minus R. So it's 1 minus 0.5. So putting that in, it's 2 divided by 1 minus a half is equal to 0.5, and 2 divided by 0.5 is equal to 4. So that entire series there sums up to the value 4. Beneath this video, you'll find a link to a Sequences and Series PDF file, which has a copy of the solutions to this Sequences and Series question that I've covered in the video. I would suggest to you that you print out this file, as it will be very useful for you to have for your revision work.